we can actually try to serve multiple users at the same time, so-called multiple user massive MIMO. In my talk, I will compare actually two massive MIMO topologies. So the well-known collocated topology, which is basically all your antennas are on one location, one device, like it's shown in the figure. You have one central processing unit, and yeah, that's the general idea on a massive MIMO system. However, in our testbed, we're actually capable of doing a distributed massive MIMO system, which means that you're actually able to move your antennas or your different. You split up your system into different parts and try to serve users this in that way. Why would you do this? First of all, there's the basic idea of, let's say you want to serve users in one room. You have a panel of antennas on one side. This is a normal collocated scenario. But what if there's a wall in the middle of the room and you walk behind that wall? Of course, this will influence your performance of your system. But what if you would then distribute your antennas all around the room? Then there's actually no line of sight scenario. So that's actually quite a big improvement. So we're reducing the shadow fading. And on the other side, you also introduce more diversity. So you're actually able to distinguish your users in a better way, but more on this later in the figures. So the general outline of my presentation will actually be first a bit on the architecture of our testbed, the hardware that we use, components. Then I would like to talk actually about our data sets, basically all the different scenarios of data that we actually are capable of collecting using our experimental setup. And then some of the results of, actually more of the recent results of one of the data sets that I will introduce. So first the architecture. There's two main parts that make our massive MIMO testbed actually very special. First of all, there's the antennas. We designed patch antennas specifically for this testbed. So you can see here we have 64 patch antennas. And the nice thing about these is actually that they're completely modular. So you can actually, here now they're organized in a rectangular pattern, but we can actually change to any topology of antennas that we want. And I will give you more on that later. And then there's of course the processing hardware. We're using USRPs, 32 to be more specific, as RF frontends. Each USRP has 2 RF chains, so each USRP connects to 2 antennas, so that makes 64 antennas. And then we have a large processing core, which is shared for all the frontends. In our experiments, we use the 2.61 GHz center frequency. That's the frequency for which the antennas were designed, and then there's the bandwidth of 14 MHz due to the use of the USBs. This is a more schematic overview of our system. At the bottom, you have all the 32 USBs connected to, this is basically an interconnection units. They're all synchronized using an octoblock. And then these 2 connection units are connected to the central processing unit to fiber. So these are actually fiber cables, which means that we can actually split these 2 parts and move them at a large distance from each other. So we can actually make a real distributed system. The MIMO processing and bit processing actually happens here, and then here there's more other processing for the frontends. Actually, also recently we are updating our testbed, so we actually are capable of making 2 different cells, which also allows us to compare the difference in actually using 1 central processing unit to using 2 processing units. So this is actually only a recent change, and we don't have actually any results with this setup yet, but I wanted to share. As for the software in the system, we use the MIMO application framework provided to us by NI. We didn't implement the whole MIMO thing ourselves. It would be a little further. But so yeah, we use LabVIEW, and we can use it to draw experiments. We use it to capture data. In that sense, it's really nice. Now, on the data sets, what we generally do in our experiments is actually we just in the massive MIMO is capable of doing channel estimations, because it's based on an LTE implementation. So what we do is actually we can do channel estimations for any scenario that we want, for any configuration that we want. We take these